So we're going to work on practice 4 combination circuits. So this part, there are parallel branches and there are a couple branches that are in resistors. So just looking at our picture, we have this resistor and this resistor in parallel. In series. So we are going to look at that. And the way I like to do it is I like to just kind of remind myself that these two will be following series rules. All right, so now let's go ahead and write down what we do know. So it's given to us that there's 30 volts in our battery. So our battery has 30 volts. In the first branch, you have resistor 1. So this is called resistor 1. In the second branch, you have two resistors, R2 and R3. So R2 and R3. And it tells us what our total voltage is. So we'll go ahead and fill in our voltage circles. This is going to be 30, 0 into the negative terminal and 30 out of the negative terminal. And so we have 30, 30, and 30. Since there's only one resistor in this first branch, we know that as soon as it goes through the resistor that there's 0 volts after it. So all the way up until the negative terminal, there will be 0. And so now what we have to do is figure out what these values are, what the voltage drop is for R2 and R3. So we can actually fill in that 30 volts will be here, and we know the voltage drop for R2 and R3 will be 30 in total. And so let's see here. Look for the one there's 2 out of the 3. So we have 30 divided by, or 30 is equal to a current times resistance. And so we have 30 volts is equal to the current of branch 1 times the resistance of the first resistor, which is 20. So we have 30 volts is equal to branch 1 current times 20 ohms. And that's going to be divide 20 on both sides. Oh, that's awful. I'm sorry. This branch 1 is going to have a current of 1.5 amps. So this will be 1.5 amps. And we know that because these are in series, this current will also be the same. So we can go ahead and write that this is going to be 1A because R2 and R3 are in series, which means that the current will be the same. And so now we also have 2 out of the 3. So we have branch 2, the voltage drop for resistor, this is going to be tricky on how do I label it. We'll just call it V2 is equal to 1A times 10 ohms. So that's going to be the voltage drop is 10 volts. So that means that R3 must have a 20 volts drop because it follows series rule. So 10 plus 20 is going to be 30. And then what this is going to look like is 20 is equal to 1 times something. That would be 20 ohms. And so because this has a 10 volt drop, this value is going to be 30 minus 10 is going to be 20. And we already know that this is 1A, this is 1.5A. So that means this must be 2.5A, 2.5A, because the total is we're going to add this current plus this current will give us this current. Okay. And so then after it drops through this resistor, it'll be 0. All right, so now let's go ahead and draw our schematic diagram. And so we have our battery, positive terminal, negative terminal. We have our total ammeter here. And we have 2 branches, resistor 1, and then our ammeter, resistor 2, and then our ammeter and resistor 3. Then our total right, so when we label it, it'll be A, and then B, C, oh, I forgot to draw the connecting part here, and D will be down. Actually, this is the part where it might benefit to do branch 2 first. So I'll go ahead and write C prime, and then D prime will be after this resistor, E prime will be before that resistor, and F prime will be after. So then we'll just copy it on this side, C, D, E, F, and then G. And then quickly fill it in. Fill in all your ammeters. All right, and we are ready to graph. So we have all the way up to G, A, B, C, D, E, F, G, and then A. And we are trying to go from 0 to 30, so we can go 0, 10, 20, and 30. So for our gold, we have A, B is at 30, C is also at 30, D will be at 0, E, and then all the way to A will be at 0. And then for C prime, it goes down to 20, so there's a 10-volt drop. And then for E, it stays at 20, and then it goes down to 0. So then we see that there's the other pathway for the charges to go through. And now, oh, we have some other things to fill out here. So we have our total current, which is going to be 2.5. And then we find out our total resistance with 30 volts is equal to our current of 2.5 amps times some number. That's our total resistance that we don't know. So we're going to divide by 2.5 on both sides. And we are going to get with a total resistance is equal to 12 ohms. And now for power, power is going to be P is equal to voltage times the current. So remember that power is equal to voltage times the current, and it kind of tells us how bright a bulb is going to be. So we're just going to multiply 2.5 times 30 for the first row to get 75 watts. And our second row is going to be 1.5 amps times 30, which will be 45 watts, and then 10 watts and 20 watts. And just a reminder, so let me fill that part out. To get this number, it's 2.5 times 30, and we have 1.5 amps times 30. We have 1A times 10 volts, and we have 1A times 20 volts to get these answers. And now to determine the brightness, we don't look at total, and we rank it from the largest number to the smallest number. So 45 is our largest number, then 20, and then 10. And so that is practice for number 1.